Muhammad AKRAM bin Muhammad ROSDAN.
Assalamualaikum, my name is AZEEQ YAAKUB.
Assalamualaikum, my name is HAZMI bin HASSAN.
So the objective in this experiment is to measure the relationship between the number of loops and the amount of field strength in the electromagnet, and to measure the relationship between the voltage and field strength in the electromagnet. So it's Friday, April 21st, 1820. A physics professor in Denmark named Hans Christian Ørsted is in the middle of a lecture, and he's using a compass and an electric wire for a demonstration. He turns on the current that runs through the wire, and he noticed that the needle in the compass starts to move. And when he turned the current off, the needle moves back to where it was. Then he runs the current through the wire in the opposite direction and sees the needle move the other way.
What Ørsted demonstrated that day was a fundamental discovery, the connection between electricity and magnetism, and it changed the field of physics forever. The relationship between electricity and magnetism not only explains that what Ørsted and his student witnessed in 1820, it also makes possible much of the technology that is today, from hydroelectric dams and smartphones.
It even explains why Earth's magnetic field is essentially keeping you from being cooked alive right now.
Next, for this experiment, it requires an apparatus which are bar magnet, compass, battery with a sidebar, field meter, and the last one is electromagnet. Now for the procedure, first thing first, you must have a compass and a bar magnet. What you need to do is move the compass around the bar magnet to know its pole. Then flip the polarity of the magnet to make sure that the pole is still the same or not. Next, we need a field meter, which is we need to put the field meter 1 inch away from the north of the bar magnet. After that, we move the field meter 1 inch away the south of the bar magnet. In this step, you can see right here that when the field meter is close to the bar magnet, the field meter will increase. The reading of the field meter will increase. If you put it far away from the bar magnet, the field meter will decrease. Now for the next step, we need an electromagnet. So like the first step, what we need to do is we need the field meter to move around the electromagnet like the bar magnet. After that, we need the field meter to move 1 inch away from the left side of the electromagnet. Then we repeat the steps by make sure the position of the field meter is the same from the electromagnet. Next, we need to repeat the steps by changing the loops of the electromagnet. So it was the first loop. Then we change the loops into 2 and 3 and 4. Then we recorded the readings in the table. As you can see right here, if we change the loops by increase the loops, we can see that the field meter will increase. Don't forget that for the electromagnet, we need a wire that connect with loops that connect with a battery that had current run through it. Now for the next step, we need to make sure the field meter is stay in this position, which is 1 inch away left side, 1 inch away left side from the electromagnet. Then for these steps, we have to adjust the voltage of the battery with the slide bar. Adjust the voltage to 2 volt, 3 volt, and 4 volt. And for the final steps, make sure you recorded the data in the table. These are the data that we required during the experiments. Now we move to the next section.
Now I will explain about the discussion of the experiment of the magnetism. So without wasting any time, let's start. Okay, after we have conducting the experiment on the magnets, we could have better understanding about the concept of the magnetism. This is because we can learn that magnets actually have magnetic field, which is the region surrounds the magnet. The other one is this magnetic field also have high values at the poles compared to the middle of the body. Okay, for example, if we look at the second diagram, we can see that the magnetic field is higher at the both of poles compared to the middle body of the magnets. The second point of the discussion is we can learn that the field strength of an electromagnet can be varied with the number of loops and the voltage. For the number of loops, by increasing the loop, the magnetic field of an electromagnet can also become increased. This is because it is stated that each loop has its own magnetic field. The second one is the voltage. As we increase the voltage, the magnetic field of an electromagnet will also be increased. This is because actually the magnetic field is directly proportional to the current. So by increasing the amount of voltage will increase the amount of current, and because of that, magnetic field of an electromagnet will also be increased. Next we go to the last part, which is the conclusion. From the experiment we can state two conclusions. The first conclusion is we able to measure the relationship between the number of loops and the amount of field strength in the electromagnet. The second one is we able to measure the relationship between the voltage and field strength in the electromagnet. That's all from me. Thank you.